and a wonderful day to you all. We are now live, so I can take this wonderful overlay away from the screen and we can start. Welcome. Today we talk about hydrogen, the most abundant element in the universe. And yes, the universe, not the Earth. We'll be talking about that later on. H2, as molecular hydrogen is called, hopes to counter climate change in many sectors. And of course, it feels like the excitement around hydrogen and building a hydrogen economy could not get any bigger. There's hardly any discussion about the climate neutral transformation of the industry where hydrogen is not addressed. And there is a flurry of activities that aim to expand the production and the use of sustainable hydrogen. Now in North Rhine-Westphalia and Germany, the state we are in right now, they want to be frontrunners in this process, and they have presented an ambitious hydrogen roadmap last year. And of course, this is also urgently needed as building a hydrogen economy still poses a big challenge. Which brings me already to the first question to you, our dear audience. Go to slido.com and type in the hashtag HotH2 and have your say. And I will enable this Slido poll right now, and you can actually see it on the screen next to me. So as you go in, you are able to give your opinion. How long does it take to establish a hydrogen economy? And we'll have our guests comment on that later on. So I always appreciate your comments and questions and protests during our live broadcasts, and we are happy to discuss them live later on also during the show. And today is actually Hydrogen Day in North Rhine-Westphalia, and I bet many of you didn't know that. So to that occasion, we actually had the pleasure of welcoming the State Minister, Professor Dr. Andreas Pinkwart, at our production site in Dormagen this very morning. Andreas Pinkwart, from whom we'll be hearing a little bit later, he's the Minister for Economic Affairs, Digitization, Innovation and Energy. And he came to see himself the construction of the world's largest plant for storing green hydrogen in liquid organic hydrogen carrier. That's a mouthful. And this pioneering plant is built by Hydrogenious, or specifically its subsidiary here, and the Jülich Research Center with its Institute for Energy and Climate Research. And they're doing this on the premises of Covestro with the support of the state government. And that finally brings me to our two amazing guests who are significantly involved in this undertaking. First, we have Dr. Daniel Teichmann, CEO and founder of Hydrogenious LOHC Technologies. He developed an innovative technology to transport and store hydrogen easily, safely, and cost efficiently. And that was the foundation of the company that will now implement this technology on an industrial scale in Dormagen. Welcome, Daniel. Great to see you.
Yeah, great to see you. Thanks for the invitation.
Wonderful. We have great sound from Dormagen. These gentlemen, by the way, are in Dormagen, both of them, and I'm happy to have a good connection. And Covestro is an investor of Hydrogenious and provides the construction ground in Dormagen, as well as, in the future, the green hydrogen that can be processed in this plant. So I'm delighted to welcome our second guest, Dr. Klaus Schäfer, our Chief Technology Officer, who also happens to be a member of Germany's National Hydrogen Council. Good to see you, Klaus.
Good morning.
Klaus, a regular guest on our home office talks, always a pleasure to see you on our broadcast. So let's go into the questions, and I'm already very, very happy to see that we are getting tons of comments and questions on social channels. This is the way to go. So Daniel, did you, by the way, know that Covestro and Hydrogenious have something in common beside our Dormagen plant? As I did the research, I found out that we were both nominated for the German Future Prize by the German president. How cool is that? What a coincidence. So the whole idea for your LOHC technology, and Daniel, you have to explain to the audience what that really means, was born when you did your PhD thesis. So let's go to the first question to you. When did you really know that this technology had such a great potential and you should build a company of it?
Yeah, that's a very good question. To be honest, I think I was feeling it quite early. It was actually after my master's degree at the university when I had actually 2 job interviews at BMW in Munich. And one of them was really in research and technology, looking into hydrogen storage technologies. And that's, you can imagine, it was the one I ended up with. The other one, and I think it's even a bit ironically, if you look back, was about, I think, simulation of combustion processes in gasoline engines, right? So quite a different world. So it was not really difficult for me to choose. And I'm really happy that I ended up with a quite innovative approach, really looking into hydrogen storage technologies. My job was really to assess different ways of doing that. And actually, in my PhD that I was doing during that time, I came to the conclusion that LOHC, the principal concept, is really perfectly suited in our eyes for the transport and logistics of hydrogen. During that time, we have also identified a very suitable substance to do that. I mean, we will talk about that later on, I guess. And yeah, actually, after having stayed at BMW for 3 years, the choice was actually rather easy for me because I decided to stay with hydrogen rather than staying with the automotive industry. And that for me was really clear because, of course, usually after 3 years, I would have switched to different departments, doing some other stuff at the car. But I wanted to stay with hydrogen, and we felt that it can really play a very important role as an energy carrier in the future. I'm very happy to now see the high momentum in the market. I mean, over the 8 years of our existence as Hydrogenious, this was not always the case. I mean, there had been some times where it was quite difficult to attract the interest of the public and of investors. But now I think it really pays off because now we are really well positioned to play an important role in this really very dynamic world that we see at the moment in hydrogen.
And then, of course, Daniel, if you would have stayed at BMW, we would have never known what would have happened then. But at least we can now see, what the rest of history, as they say. Klaus, as the CTO of Covestro, you are, of course, constantly in touch with innovative ideas and new technical possibilities. So, Klaus, how important is it to you to be courageous and give these innovative ideas the necessary space to develop, even though there is really no guarantee of success?
Nico, there are 3 things which are of utmost importance. That's what you have said. It's courageous, it's curiosity, and it's openness. It's very important, and I'm a big believer in openness in technology. And we must not prematurely settle on solutions and shutting down promising other routes too early. We need to find out the best solutions. Curiosity is something which has led us at Covestro to discover new stuff, and courage has helped us to realize them and to try them out. So that are the 3 elements which I think are absolutely essential to drive things ahead.
Cool. And actually, we asked our followers, we made a small survey to learn how they see the potential of sustainable hydrogen for the climate neutral transformation of various sectors. So let me bring up the results and see what we got. Let's look first at LinkedIn. Here we go. On LinkedIn, we asked the people who follow us, where do you see the greatest climate protection potential for sustainable hydrogen? And we had 660 votes. Thank you very much for voting. And 84% went for industry applications. So yeah, a little bit less than half. And pretty much the rest went into mobility and logistics. So I think this was an interesting outcome. I can also show what our followers on Twitter shared with us to the same question. We had less votes here, but the Twitter folks seem to be thinking that industry is the greatest potential for use of hydrogen. Any commentary from your side to these results?
Yeah, of course. I mean, I think the general picture I fully agree with. I mean, I think hydrogen has really a great potential in industry and also I think in heavy duty mobility, because that's the sectors that are very difficult to decarbonize with pure electric energy. And therefore, I mean, you need a chemical energy carrier like hydrogen to decarbonize them. And therefore, that's a great potential. And what I also like to see here is that I think this is a very good and realistic picture, and it's a bit different to what you would have seen maybe 5 or 10 years ago. And what you see is that people do not only associate hydrogen with cars anymore. So that was the case 10 years ago when you said hydrogen, everybody was about the car only. And this limits the potential of hydrogen because hydrogen is so versatile. You can use it to decarbonize steel plants or refineries. But of course, also heavy duty mobility. And I personally also believe in hydrogen passenger cars. I have Nexo for myself for the last 1.5 years and absolutely happy with it. But of course, you can argue between batteries and fuel cells and so on. But hydrogen is not just cars. And that's, I think, a message which now is really clear. And this is really helping the whole industry to really see the full and broad potential of hydrogen.
And this is and you should know we are coming back to that. Klaus, you are also representing the chemical industry in the National Hydrogen Council of Germany. So Klaus, why is sustainable hydrogen so important from the industrial sector? As we could just see from the poll, the majority thinks to believe that it is exactly the industrial sector which is able to reap the benefits.
I think if you look to the industrial sector, it's the sector which really requires hydrogen for next steps of the decarbonization. The result itself is not surprising to me because it somehow reflects the public discussion we are seeing around hydrogen and the use of hydrogen. Nevertheless, I'm convinced that it would be a mistake to focus on one sector only. We right now have a situation where we have a lack of supply, we have a lack of demand, and we don't have the transportation means, either the hydrogenious technology or pipelines or even other technologies. Yeah, it's not really developed on a type of industrial scale and used at an industrial scale. So hydrogen can only make a significant difference if we bring it to an industrial scale, if we bring it into huge volumes, and therefore all the applications will help to develop demand, and then also with the demand, I'm convinced the supply will be developed, and we need to focus on establishing the transportation needs.
Thanks, Klaus. And Daniel, one thing that we could also see from these results is that transportation and mobility was a runner-up. So why has sustainable H2 has such a great potential for these applications from your point of view?
I think first of all, the transportation sector really has like the biggest problem of all sectors, right? In terms of like CO2 emissions. Because if you really look at the development of the different sectors since 1990, I mean, there was huge progress in electricity generation already and in buildings and so on. But mobility sector or transport sector stayed really roughly the same. I mean, if you like, you can say that the improvements in efficiency of the cars got somehow counterbalanced by the cars getting bigger and more powerful over the years, right? And therefore, we still have roughly the same emission level. Therefore, there's a huge stress to do something there. And it is a sector, especially in heavy-duty mobility, that's very difficult to decarbonize. I mean, batteries can work very well for passenger cars, but I mean, nobody can imagine like running ships, for example, or trains, or maybe also like heavy-duty mobility, like buses and trucks, really fully on batteries. And there, I think hydrogen can play a very, very good role to do that. And that's what we're absolutely seeing already. And we as Hydrogenious are also focusing on the transport market in two directions. One is that, I mean, we are also active in the supply of hydrogen refueling stations via LOHC technology. So we will, in the course of this year, open up a hydrogen refueling station in Erlangen, which is the first one which is supplied by LOHC instead of conventional ways. So that's the first angle. And the second angle is that also we're working on getting LOHC on board of ships as a fuel directly. So really to use it, to bunker it in the existing tanks of the ship, and then to release it on board and feed it into a fuel cell. And that we believe is really quite an exciting application as well, because within the transportation sector, the shipping sector has even the bigger problem, because they are even further away from really being carbon neutral than other sectors of the mobility sector.
Cool. At this point, I again remind our wonderful audience to join in the conversation, and I see I don't have to even remind them because they are already in the conversation. I would love to take one question already from the audience, if that's okay with you, gentlemen. Just a second, I will put it up here. I think this is an interesting comment we are getting live from LinkedIn, also regarding the colors of hydrogen we are being used. I want to ask your position. Do you think only green H2 is to be used? In North Rhine-Westphalia, we have plasma oven to produce 22 tons of H2 per day at the acetylene plant in Marl. This could be considered as turquoise H2. What is your position? Any color commentary from the gentleman?
Yeah, let me reply to that. I'm convinced that to develop a hydrogen economy, we need to build on different sources of hydrogen. Yeah, of course, in the long run, green hydrogen coming from electrolyzers fed by renewable energy, by renewable power, is the dream situation, the dream setup, of course. On the way to that, I'm convinced we will need to use turquoise and also blue hydrogen, using CCS for that, using CCU for that, simply to get enough hydrogen supply into the market, also during a time where we do not have enough green power yet. So to make sure that is going hand in hand, and that there is enough hydrogen to develop the market, I'm convinced we should not go into one direction only. We should use all our opportunities, and also remembering what I've said earlier, openness to different technologies, and let over time find us out what is the best technology and the best solutions is the right way to do. So from their perspective, that hydrogen is needed.
Thanks, Klaus. Before I go to another question, or we look at the polls from the audience. Daniel, any commentary on turquoise? Let me show you the question again.
Yeah, to be honest, I'm not an expert in turquoise hydrogen. I mean, there's so many colors by now, right? There's white and purple and whatever. But I mean, I fully second what Klaus just said. I mean, of course, in the end, I think I'm really coming from a position where we say the vision is to really have green hydrogen, or let's say really completely intrinsically emission-free hydrogen available. So that's what really we're striving for, what we want to accomplish. On the other hand, I mean, you really don't need to see it pragmatic in that way. I mean, it's a big challenge. And of course, what we need to do is not only securing the sources of hydrogen, but also having the off-takers ready, right? And let's say for a steel plant to switch from the coke that they're using today to hydrogen is already a big step, right? And for them to make that happen, I mean, they need large quantities of hydrogen, and that mustn't be too expensive in the first step. And therefore, to enable it that they transform their processes, I mean, it absolutely makes sense to have also other kinds of hydrogen available. And therefore, I think this is necessary, but it should not distract us too far from that. I think the future scenario should really be one where you have really fully emission-free hydrogen available. But I think it's not really a contradiction. We need both in the beginning.
Right. So green is at the end the color of the forests. Let's take a look at our Slido poll where we are right now. We have 16 live votes. Let me bring them up. Here we go. We ask our audience, how long will it take to establish a hydrogen economy? And forever and no time at all is not getting any votes. We have a split situation between 2030 and 2035. And of course, some have been skeptic about the rapid market ramp up of green hydrogen. Some even call green hydrogen the champagne of energy transition. So looking at also these results, and we're getting one more. I love live. What do you think? Will the market ramp up of green hydrogen succeed? So Daniel Klaus, speaking of the market ramp up, hydrogen technologies seem to be developing rather slowly. Any ideas why? Klaus?
I think if you think about development of those technologies, there are several elements. There's on one side the element it needs to make economically sense, financially sense for the companies doing that. Yeah, the industry is not able to subsidize technology over a longer time. We can do that for a short time by starting stuff. That is one of the elements. The other element is that those things need time to be built. If you want to build a bigger plant, electrolyzer plant, if you want to build a plant which is going to use that hydrogen, with the engineering, with permitting, with construction of those plants, that are lead times of type of 4 to 5 years. If you have technology which are not in a technology readiness level 9, but in an earlier phase, you need to go via further scale up steps. It's the risk we usually have is that we compare the industrial technology with those type of mobile technologies where things are changing every other year. That is something which is with the industrial plants not possible. So that is why it requires time.
Yeah, maybe just to add to that, I fully agree. And I think what we talk about here in terms of introduction of renewable hydrogen, I mean, this is, I think, one of the single biggest transformation in our energy system that we have seen for a long time. I mean, of course, we have seen the introduction of something like wind and solar as renewable energies, but this is really a massive transformation. And therefore, the expectation definitely should not be that it's something that within a few years it's all done. No, this is a challenge, but also an opportunity for everybody over the next years and decades, right? I mean, we're talking about 2020, 2030, 2040 there. But I think it's absolutely worth it. And I just wanted to comment quickly on this champagne of the energy transition, because I mean, I've known that, and I know that quote, but I think it's actually very misleading. And I think it's coming from people that are maybe not in favor of hydrogen. Because champagne, I mean, is something that's very rare and very expensive, right? And that's not at all what green hydrogen can do in the future and what the idea behind it is. Because what we want to do is really making renewable energy in the form of hydrogen really available at very low costs at industrial sites like here in Dormagen. Because for that, you need to look into the regions where you have the best potential for renewables, like Southern Europe, like wind parks offshore, like North Africa. And then, of course, building power transmission lines doesn't really work over these distances. Therefore, hydrogen is really a vector to bring these very cheap renewable energies to Dormagen here and to the industrial centers, and therefore really make it very cheap energy, very cheap availability. And therefore, I think this champagne idea is quite misleading and is absolutely not what we are working on to establish.
So no champagne in the mix, which I think seems sensible given the importance of this whole topic for the sustainability of the planet. We actually had Minister Pinkwart join Dormagen this morning, and we have a clip provided by our roaming on the ground reporter Przemek Jedrusik. Thank you, Przemek, who met the minister this morning and asked his views on the topic. Let me bring it up and let's watch it together and then comment on it.
As a people here to transform our industries and stay in forefront also in the future, making sure that we can build on made in Germany with best environmental conditions.
Thank you very much.
Thank you so much.
And I will play it again because I think we had
So I have
in the
only
beginning.
one
Here we go.
question.
Yeah.
Which role does hydrogen play for North Rhine-Westphalia, and how can we build a successful hydrogen economy? What role politics does play in this?
Yeah, I think that you have to start early, that you have to collaborate very closely with industry, with sciences and politics. That's exactly what we are doing here with our initiative In for Climate, where we work very closely together with all three parties, and that you have to invest in these new technologies as we do here with Covestro and the partner company. And you have to start with some really excellent projects. You have to identify new technologies. You have to prove. You have to make sure that there's also competition of different technologies, that you can find the best one in the future. Yeah, you have to be an early adapter, you have to be an innovator in that field, and you have to stay optimistic. That's our understanding here in North Rhine-Westphalia.
And the state government is committed to really staying at the top of the
Yeah, we're really committed. We love to support our industry to be in the forefront in these new technologies, because we are sure that we have the capacity here, we have the knowledge here, we have the people here to transform our industries and stay in forefront also in the future, making sure that we can build on made in Germany with best environmental conditions.
Thank you very much.
Thank you.
All right. There was the greetings of Minister Pinkwart. What are you, do you agree with this vision?
Yeah, absolutely. I mean, I absolutely agree. And of course, we are very happy for and very thankful for the great support from the state government here in North Rhine-Westphalia. I mean, it is absolutely clear that new technologies and hydrogen in particular, I mean, they require the right framework. So they require political but also regulatory support for a successful ramp up. And therefore, it's absolutely necessary that the state steps in and supports this. Yeah, and I believe that really hydrogen and maybe also our LOHC technology in particular fits very well really to North Rhine-Westphalia and also, of course, the whole region here, because it's really industrial heavy. So you have a lot of industry here, you have a lot of quite energy intensive industries. And I mean, what we try to do is really facilitating the continued usage of existing energy infrastructures that we have here in the region, and also really making sure that energy intensive industry can also still exist in a future renewable energy world, because I think we don't want that all the steel plants are only located in Southern Europe in the future, because that's where the cheapest electricity will be. But we really want to make sure that they also can exist here. And for that, you need something like the import of green hydrogen. And we believe with the LOHC technology, we can really contribute to that, making it really not the champagne, but really the quite cheap but high quality water that you need here for feeding the industry.
Cool. Klaus, what are your thoughts on the minister's comments?
Yeah, I think it was great to have Professor Pinkwart here this morning, and also to see the support of the of North Rhine-Westphalian state for this project. It's not only about the support of the project, also on R&D activities we are doing with the RWTH in Aachen. There's a lot of support. And that really drives us ahead and gives us opportunities to realize things which would be difficult to be realized without that support.
So moving on, what is the role of the industry, and how can the industry itself contribute to this goal, and the role of collaborations? The collaborations are the way to go in this building a hydrogen economy. Maybe Daniel, if you start on that topic.
We believe that really corporations are highly success critical. I mean, currently supply chains for green hydrogen do not exist yet, right? So that's really a new business. And therefore, I mean, it needs joint effort and the positioning of many different players to make it happen. But of course, I mean, this transformation of the energy system also, of course, offers huge opportunities for first movers, right? And therefore, I think it's really a good time for innovative businesses to establish. I mean, we in our Hydrogenious related projects are very open always to partners. I mean, yeah, I think the plant here in Dormagen together with Covestro, but also with our other shareholder FOPAC, it's a very good example. I mean, we're at the moment developing projects across Europe. They have names like Blue Danube or Green Crane or Aquaventus here in Germany is another quite interesting project. In all of these projects, we work together with, I would say, the who's of the European industry, because all the big players really try to get their feet into the hydrogen market at the moment. And I mean, of course, Hydrogenious, we have a transport technology, but we see Hydrogenious not only providing the linking technology, but also playing a role in linking the different players on the market by our quite proactive project development. And that's really the key, we believe, for success. We'll be very open and working together with the other players in the supply chain.
Thanks, Daniel. Klaus, Covestro is also involved in different hydrogen projects. So where do you see the main benefit of such collaboration? And maybe if you relativize what we're doing here compared to the hydrogen topic overall.
What I see clearly is that we need to break the waiting pattern. We have here a type of chicken and egg problem, and transportation is one of the elements. And Daniel has said that establishing this hydrogen economy is a huge challenge because we need to work on the supply structure, we need to work on the transportation structure, and we need to work on the demand side. And that is something, and we have seen that in other areas in the past. If you think about electrical loading stations for electrical cars, these things need to be pushed over a certain hill to get rolling and to get type of self-entertaining that. And that's the reason why we are involved in this project, but we are also involved in the Rhine project. That is where we convert the ships which were sold in our locations here in NRW to H2-powered barges. So that we have also a demonstration.
Ich habe im Internet leider nichts zu Daniela. ZDF-RTL ist der Wissing HRNLK-Messe Challenge, wie groß wie I need to work on the Preisstraße.
This is the first time we're getting Alexa or somebody
something going wrong with this computer. Can you hear me?
Yeah, absolutely. This is a great an element of live broadcasting. With the touch of a button, you have a read aloud screen. No problem, Klaus. Go ahead.
I think by gesticulating with my finger.
It's a gesture control. Yeah.
Shouldn't have touched. So with this Rhine project, what we try to do there, or what we are going to do there, is to convert barges which are supplying our sites with salt. To convert them to be driven by hydrogen, which then can come out of our production sites. So it again fits in this great structure of chemical parks where you have all these different opportunities. It's very much a similar concept to the Hydrogenious plant here, which is going to use green hydrogen being supplied by Covestro. The excess energy as heat and steam on a very good temperature level from Hydrogenious can be used in the chemical park again. Yeah, that type of integration, that type of reuse of everything which is there is really driving things to more sustainability.
Thanks, Klaus. And to all our audience, you cannot fake this. So this is a greatest proof that this is a live broadcast when something like that happens. So we appreciate when always this happens. But this is very inspiring what you say, Klaus, because when we have barges which are running on hydrogen, when we have trucks who are actually powered by hydrogen, we are really getting closer to that dream of less emissions and no emissions in the end. So being also a truck driver, sign me up, Daniel, when you have the first trucks driving. I'd be happy to get behind the wheel and get the goods going. Let's come back a little bit to Dormagen, because Daniel, for you, Dormagen is what makes this project so special, and why have you chosen Dormagen for this pilot of all the places?
Yeah, Nico, I think that's a good opportunity also to describe a bit clearer what we do in general, because I've also seen a few comments here asking for that. So, I mean, we have talked about these large amounts of green hydrogen that need to be supplied to industrial off-takers in the future, and sometimes really need to bring them in from long distances. And I mean, there are conventional technologies like high pressure storage of hydrogen, cryogenic hydrogen, and some derivatives like ammonia and so on. I mean, what we as a company have developed over the last years is a
future
so-called
world with renewable
LOHC
energy and
technology.
mobility. Its importance as an
You
energy
can see it
source.
there.
Yeah, I turn off the audio just to
You see
show.
it, yeah, and I will give the audio to it. It's really a technology called LOHC, liquid organic hydrogen carrier, which is about the storage of hydrogen in a liquid carrier substance that is fully compatible with the existing infrastructure for liquid fuels. So what we do is, and that's what we also do here in our new plant in Dormagen, is really binding hydrogen chemically to that oil. You have seen it, I think, in the video a few times. You see it in the glass bottles there. And the big advantage is, I mean, that's not molecular hydrogen anymore. So all the things that you know, low density, safety issues and so on, is gone. You only have to handle an oil which is hardly flammable, which you can store in existing tanks very easily in very large quantities at ambient condition. And that makes, of course, the whole hydrogen value chain much easier, and it's also much more cost efficient. And that is the LOHC technology that we have developed and that we have implemented over the last years already. I mean, we have built plants in the United States already. We have sent systems to Finland, Germany, a couple of them. And now it's really about upscaling of this technology and of these plants into really a fully industrial scale in industrial context. And that is exactly what we plan to do here in Dormagen, really building the first of its kind large-scale industrial storage plant. So the storage plant is where actually the hydrogen is being bound to the liquid, to the carrier. And therefore, we do this in a really large-scale setting. I mean, we have seen the picture before, how this will look like. So this is not a container anymore, but really a larger chemical plant. So you see it here, the minister and myself beside it, there you see it. And that's, I think, why this is quite unique, because this is really the largest scale LOHC system that's there so far. And it is really a scale that is not anymore lab scale or piloting or something. This is really full industrial scale. And I mean, we can store 5 tons of hydrogen per day. And just that you have a little comparison, I mean, with 1 kilogram of hydrogen, you can drive a car roughly 100 kilometers. And therefore, 5 tons of hydrogen, 5,000 kilogram, is already, if I'm not calculating wrong, 500,000 of kilometers, the energy equivalent that we store in LOHC every day. And then the loaded LOHC is being brought to off-takers like in Rotterdam, in the Port of Rotterdam area, to the refueling stations. I mean, we're opening one in Erlangen this year, or to other off-takers in the region. And that's what we want to do here, really bringing the technology from a, let's say, pilot scale into full industrial scale.
Cool. And let me again show how the trust and belief in a quicker uptake is actually growing. We now have the majority of the voters going for 2030 instead of 2035. So that's definitely a good signal. We'll be going to take the audience questions very, very soon next. But before I go there, Klaus, how can you again explain how is Covestro now supporting this project that Daniel just explained to us?
Yeah, Covestro is in that project via different channels. One channel is that we will supply green hydrogen to Hydrogenious, to that plant, so that it can be bound to this organic liquid and transported and used by Hydrogenious. We are in this chemical park also the owner of the land. We are supporting Hydrogenious to integrate that plant into the chemical park, and we have decided to invest with a low percentage number into Hydrogenious itself, also to show and demonstrate that we are going into a close cooperation here, and that we really want to make that project a success.
Thank you. And I'm scrolling through the questions to find one. There's one question which I think pertains to that, which I'm trying to find. I will just read it to you because there is a question from the audience asking, can you please identify the resources for green H2 for the long term? So this is an audience question. Where do you see the green, the source for this? So I think it's this is going into the direction of renewable energy sources. Can you talk a little bit about that?
Yeah, perhaps I can start with that, and then Daniel can continue that. I think the more important thing is that we are coming to a climate neutral production of hydrogen, and then it can be type of different sources. Then it can be green, it can be blue, or it can be turquoise hydrogen. The main focus is to avoid the emission of CO2 during that production, and also during the production of required energies and raw materials. If we are talking about green hydrogen, we are usually thinking about water electrolyzers, which are fed by renewable energies, so by renewable power, no CO2 emission during the production of that power, and then also the hydrogen is green. You know that we as Covestro have signed a contract, at that time the biggest PPA with Ørsted to buy 100 megawatt from wind power from the North Sea. That project will materialize or will start delivering in 2025. In the meantime, we have signed a contract with ENGIE in Belgium to supply our Antwerp site with green power, and we're continuously working and identifying, negotiating opportunities with the power supplying industry to increase that share, and also to find opportunities to do that even earlier than 2025.
Thanks, Klaus.
Maybe I can just add one thing. I mean, green and all the numbers, the colors, I mean, it's of course a question of definition in the end, right? I think what is important is, of course, to have production technologies that do not produce carbon emissions. And that can be renewable energies and then going into an electrolysis, splitting water. Or, of course, it can also be other production methods of hydrogen. And I mean, I think the turquoise hydrogen was mentioned. I mean, that's a similar idea where you're using a fossil feedstock, but you're not emitting CO2 into the air because you have actually solid carbon in the end. So that something like that could also work, I think. There are other things like white hydrogen where it's just coming out of the soil. There is very rare availability of molecular hydrogen underground. It's not really clear yet if this is really a real thing and if it will happen in larger scale. But I think there's a number of things. The only important thing is it needs to come without carbon emissions over the whole life cycle.
Thanks, Daniel, and thanks for the great questions. We'll be taking maybe a couple of more of them as we approach the end of the broadcast. But before we go there, let's talk a little bit ahead, and let's wager a bet into the future. The commissioning of the new LOHC facility in Dormagen is scheduled for 2023, so 2 years from now. So the question to both of you: how far along are we with the hydrogen economy in Germany and Europe 2 years from now? So as this plant goes on stream.
Yeah, absolutely. So I think also in regard to your question about when do you see hydrogen economy? I mean, of course, until we see it really in full scale and everywhere, I mean, I'm absolutely clear this takes some time. But yes, our plant here will already start its operation in 2023. So I think that's not too far away from today. And I think in regard to the future, my biggest expectation actually is that the regulation around hydrogen, renewable energy, carbon pricing, and so on has developed significantly up to that point, right? Because I think hydrogen is really ready to be implemented, and that's what we're doing here. I think a lot of companies are eager to do so. And I mean, let me also say at this point, we're very thankful for the support of Covestro in that. So of course, something like that would not be possible without strong partners. So we're very thankful for it. So you see, I think companies are ready and are eager to implement that. But in the end, I mean, it all depends, if you're honest, on the regulatory framework and in the end, the seriousness behind our efforts to really fight global warming, right? Because I mean, if it wouldn't be for regulatory frameworks and carbon pricing and so on, I mean, burning of fossil fuels is just cheaper, right? It's just the way you would do it. Therefore, I mean, we need the strong effort, of course, from the public, really putting pressure also on the politicians. But then, of course, the politics and the regulatory side really changing the boundary conditions. So that you can really have a business case with green hydrogen. And then I'm absolutely sure there are so many players out there with great technologies, with great competencies. They're very eager to step in and to make it happen, but it cannot work really without a solid regulatory framework around it.
Thanks, Daniel. Klaus, what's going to be the situation in 2 years?
Looking into that, I would see that becoming a significant contribution also to the CO2 reduction will be somewhere between 2030 and 2040. One thing is it's time required to build the assets. I fully support what Daniel has said, that the incentives to go into this direction need to be increased. Pressure needs to be increased. Having said that, we need to avoid that industry simply is going into other countries. So we need to maintain level playing field with competitors in different countries. The other important thing is that we need to speed up building green power generation facilities because it does not make sense to produce power by coal or gas-fired power station and then use that to produce hydrogen. So it needs to go hand in hand with a significant growth of renewable energies, and in that case, it's about renewable power. And also, when I look to the timescale for shutting down the coal-fired power stations, that will be in that frame between 2030 and 2040.
Thanks, Klaus. And let's take further questions from the audience, which we have a couple of interesting ones, I think. I think this one goes to Daniel first, from Homan Zahedi. Thanks for the question, Homan. How is the stored hydrogen actually released, and how efficient is this process? Daniel, want to take this?
Of course, yeah, that's a very good, important question. I mean, I've described the way how to store hydrogen in the liquid. I mean, that's what we will do here in Dormagen. And then, of course, there's another process, which is quite the mirror process of it. We release hydrogen from the carrier. And then the carrier is not consumed in that process, but it goes back to the source. So it's always going in a cycle and it's being reloaded. The two processes of storing it in the liquid and extracting it from the liquid have some heat associated to it. And actually in the storage process, which happens here in Dormagen, we produce heat. And that is actually generating steam that we feed into a steam network here. So this is not being wasted, but it's being used. And actually you also reduce carbon emissions here at the site because you don't have to spend as much natural gas in order to produce that heat. And then on the side of where hydrogen is going to be released, let's say, for example, Rotterdam, where we're planning to build the first 1.5 tons per day release plant, and to feed some off-takers, there you need actually the same amount of heat that you have generated in Dormagen. And therefore, I mean, of course, in Rotterdam, we can also take it from an industrial heat network, which makes it pretty simple. I think the one important aspect of LOHC technology is that you're not losing any hydrogen in that process. And that's different to some of these synthetic fuels, because, for example, if you produce methane from hydrogen, right, hydrogen and CO2, you can produce methane. But in that process, you always lose a certain part of the hydrogen because you're not only forming methane, but also water in that process. So you have an intrinsic heat loss. And that's not happening here. So all the hydrogen that's being bound to the carrier can be released again. But of course, you have these heat associations that I mentioned. And therefore, of course, a wise and reasonable integration into what you have on the specific site makes, of course, a lot of sense.
Thanks. Thanks, Daniel. We have another question, I think, pertaining to the country topic that Klaus was touching upon earlier. Let me show this question up. Just a second. Show this one as well. This is more of a comment. There's so much hype about hydrogen, but no visible milestones. Thank you for the comment. But actually, there is a question I wanted to show, and it's here. Thank you, Anutosh Shukla, for the question. What do you think in developing countries like India, when such technology can become possible? Where the basic issue is infrastructure? Also, is Covestro has any plan for India? Klaus, you want to take this?
Yeah, in India we have a number of downstream production sites. We don't have a site there where we generate hydrogen as a byproduct or so. Yeah, so we don't have that opportunity what we have in Dormagen and in other bigger sites of our company. Having said that, I'm convinced, and Daniel can explain that much better, of course, that the hydrogenious technology can be used everywhere where you have a similar industrial infrastructure to get access to the hydrogen and to get or reuse the heat which is generated there. And I'm convinced there are a lot of sites in India which have those conditions.
Yeah, maybe just to add that one thing, I absolutely agree with what Klaus said. I mean, can you really imagine the build-up of a high-pressure infrastructure across the whole continent of Africa, for example, right, or other regions? I think it's quite difficult. I mean, even we are struggling a lot because it's huge investments, it's quite complex technologies and so on. And therefore, of course, using existing infrastructure for liquid fuels that are already there everywhere in the world, we believe helps a lot. And it also makes the implementation easier in an incremental way, right? Because you don't have to install huge infrastructures before you can even start with the first few kilograms of hydrogen, but you can start quite easily using existing tank trailers or whatever. And therefore, I think this question of how can you use technologies on a worldwide scale with the different boundary conditions is an important aspect where we see a good argument and advantage for LOHC technology.
Thank you. Thank you, Daniel. As we are getting the questions rolling in, I just want to ask, gentlemen, if there's something you find specifically interesting that you wish to comment on. Are really great questions, I think. You want to.
I mean, there are a lot of questions on the technology. I mean, I think it's not spending too much time on it, but maybe a quick comment. I mean, is the liquid pumpable as oil? Is there some outgassing steel McDrive pumps? So yeah, that's the big advantage, that it is actually an oil. And of course, it has a viscosity and density and so on, which is really typical for actually our current fuels that we use as well, something like diesel or gasoline and whatever. And therefore, you can use it in existing infrastructure. I mean, of course, there's some things that you always need to look into in terms of which steel materials you're using, and of course, what is the temperature level. I mean, if it's getting really, really cold, then of course you need to look into viscosity and so on. But I mean, that's basically the same for diesel as well. So therefore, this is really standard existing technology that we're using in that part, and that makes it so easy. Of course, on the process part, on how our systems work and so on, that's of course innovative and that's new. But the whole handling and storage of the liquid, that's really very conventional technology that exists for the last 100 years.
Thank you very much, Daniel. Lots of interesting stuff coming from our live audience. Thank you so much. And actually, I will pick one. Unless, Klaus, you see something you want to jump on immediately, I will. As we wrap up. But feel free to jump into something. But this is, I think, something that has touched, has been on many parts of the questions from Helena Grababevich. Sorry for pronouncing your name wrong if I do. Her question is, do you see differences around the world regions when discussing the H2 economy? And do you see Europe as a driver? So this is, I think, really, really interesting. Maybe building up what we just discussed about India and developing countries. How do you see it from the world region point of view? Where do we see kind of the fastest progress? And as we heard from Minister Pinkwart, is Is this where the rock and roll happening, or where? How do you see this?
What I see is that Germany, looking to Berlin, looking into the politics, wants to use that as an opportunity to bring Germany and German economy in a leading position in that technology globally, developing also opportunities for exporting technology in that area. And I think that's a good starting point. There's an ambition which really drives the development ahead. When I look around the globe, I see significant developments in Japan, in Korea, and in China. They are going ahead with huge speed. Particularly, Japan tries to tap into renewable energy resources in Australia. They're a little bit closer to Australia than we are, but also that is even huge distance there. And also technology-wise, they are driving developments very quickly. And I think from a country perspective and from a competition perspective, it's important to follow that and to pay attention what they are doing if we want to keep a leading position in that development.
Thanks, Klaus. And Daniel, let's get your final comments before we wrap up. We're getting tons of questions, so it looks like we have to do this again once the actual plant is running in Dormagen. So we have to come back to this. And thank you so much for all the great questions. This is the great way, to get to the bottom of this. But Daniel, from the world perspective, where do you see where the future rock and roll is going to play? And obviously, you're going to make the rock and roll. But how do you see this going forward?
Yeah, I think the question was, is Europe leading here, right? And I think if the question would have been asked 2 years before, I think the honest answer would have been no, right? Because, we're seeing that in Asia, and Klaus mentioned it, already for the last 5 years, there's huge momentum, right? In Japan and Korea, but also in China. So therefore, we should not be under the illusion that really Europe is the only one really pushing there. What I must say is really over the last 1 to 2 years, the momentum here in Europe has really picked up immensely, right? So we're really seeing huge momentum. We're seeing huge support also from the public, but the political side, we see large-scale programs being developed also by the European Union, how to build up infrastructure, how to fund also hydrogen technologies. So I think if we keep that ambition and if we keep that momentum, I think Europe is actually very well positioned because there are a lot of companies here with great technologies, with great effort. So I think we have now a very good position, but we should also not be under the illusion that other regions, especially Asia, are behind. And I think we really need to keep up that high momentum and really be bold and be ambitious. Otherwise, I think it will be other parts in the world where this is being pushed anyway. So therefore, yeah, keep the momentum. I think that's what I believe is necessary. I think the ambition is big, so it's certainly not easy. And of course, the expectation should not be that within a few years you have all the hydrogen economy there and that's it. That's not the case. It's really a big thing to do. It's something that will take 10, 20, 30 years to really be fully implemented. But I definitely believe it's worth it. And I believe that Europe should be at the forefront and should be really ambitious in driving that forward with all the measures that we have discussed here and that are necessary to make it happen.
Thank you, Daniel, so much for your commentary. And we can see the latest poll shows that even now 50% of our voters are saying that the hydrogen economy will be established by 2030. So that's only 9 years from now. So that's very promising. So we obviously have to do this again. So next time we'll live stream directly from Dormagen as we see the plant rising up and beginning production. So thank you so much, Daniel and Klaus, for taking your time out of your very, very busy schedules, I know, to discuss this crucial topic on our way to a more sustainable world. So good luck with the project. Stay safe and stay healthy. Bye-bye.
Thank you so much. Bye-bye.
Thank you.
And thank, of course, always to our amazing audience. I mean, your participation in these live press, which make it so exciting for all of us, especially when something goes wrong, like with the Alexa or whatever it was with Klaus's laptop over there. So thanks for joining in. Thank you for your questions. We will be live again soon on another topic on future cities and sustainable living. So keep following Covestro. Until then, stay safe and stay healthy. Bye-bye.